Hey everybody. Yesterday we looked at reaction of alkane. We did two reactions. We did combustion, then we did this one, substitution. Well, what are we substituting? Well, we're substituting hydrogen with one of the halogens in a halogen gas. And I left you with this question for homework. So we have pentane reacting with chlorine gas under the influence of UV and heat. Well, I took the liberty to show you the answer. Chlorine, okay, can attack obviously any one of these hydrogen, any one of them. And it seems like, of course, it can attack this one to form this compound. Now, it's not just this one. It can attack this one, this one, this one, this one, or that one. They will all give you one chloropentane. Now, if chlorine were to attack this or substitute this hydrogen, you will get this compound, which is, of course, to be named 2-chloropentane. Chlorine can also substitute this hydrogen to give you 3-chloropentane. Now, can I substitute this hydrogen? Of course you can, but that is just still 2-chloropentane. Anyway, that's I guess that's the hard part about organic reactions, is that you can have multiple or different outcome depending on the reaction itself. So today we're going to look into more reactions, of course, stemming into more scenarios. So let's clear this page and let's start. All right, so today we're going to look at two things. Part A, okay, which is, of course, let's not call it part A. Let's just call it number 1. So we have dehydrogenation of alkane. Okay? Dehydrogenation of alkane. Now, what does the word dehydrogenation mean? Now, you might have heard that in biology again. Dehydrogenate something. Dehydrogenate saturated fatty acids. Well, when you dehydrogenate saturated fatty acids, they become an unsaturated fatty acids. Now, how does that work? Very simple. This is basically take away hydrogen, 2 hydrogens, of course, from an alkane to become an alkene. So what you're taking away is what we call adjacent hydrogen. So let me just show you very quickly in terms of how this works. Okay, well, let's not go with something so complicated. Let's go with just ethane. Okay, here's ethane. If you put ethane, which is of course an alkane, under the influence or under the catalyst of iron 3 oxide, these are very important or else the reaction will occur. What happens is this. This is the cool thing that happens when you put an alkane under the catalyst of iron 3 oxide, is that these hydrogen, which we are going to call adjacent hydrogen, will get together to form H2. Okay? Now, when that happens, this carbon is missing a bond, this carbon is missing a bond, so it only makes sense that they bond with each other again, because they're already bonded with each other. So what you're going to get here is an alkene, because carbon must make 4 bonds. Alright, so if hydrogen was taken away, these carbon needs one more bond. So they will bond with each other to form an alkene. Let's write the general reaction down, and then we'll look at more examples. So we have hydrogen gas plus an alkene. Okay, as I said, you might have seen something like this before. Okay, like the dehydrogenation of fatty acids, which in turns from saturated fatty acids into an unsaturated fatty acid. All right. Let's take a look at some more examples about this. So if I have this guy, notice I'm drawing a lot of structural formula right now because structural formula is probably the way to go if we're illustrating reactions. Of course, later on, once I know you guys are getting more comfortable to this, I'm going back to condensed formula. All right, so here it is. Dehydrogenating butane. So what are we going to get? Okay, so remember, to do this, you can take away hydrogen from adjacent atom. Now, adjacent carbon, which means these are not adjacent carbon. These two hydrogen are not going to get together because it makes no sense for them to get together. These are adjacent carbon. So taking these two hydrogens away to form hydrogen gas will indeed, of course, give you this compound. Okay, which we call 1-butene. Now, there's a reason why I decided to write the name of this, because obviously these two are not the only hydrogen that can do dehydrogenation. These two can also do the same. Or these two. You can say these two too. Remember when we would build these things, these bonds are free rotating. Okay, these guys can get together. Now when these two guys get together to form H2, you'll end up with this. Okay, which is, of course, 2-butene. Now, this is the cool part. Dehydrogenating fat is not a good thing. Why is it not a good thing? Well, because there's a chance. The chance is this. If you were to take away these two hydrogen and you make this, that's fine. Because if you look at the complexity of these two double bonds, you'll see something called geometrical isomers. This is a cis-2-butene. But however, if you were to take away these two, okay, you can actually end up with a trans-2-butene. All right? So when you're dehydrogenating fat, there's a chance where you're actually going to make a trans type of unsaturated fatty acid. And we all know that trans fat have, they put a lot of stress onto your blood vessels. Okay, something, of course, not very good. So that's why, taking solid fat and liquefying them under very, very high heat and then use it to fry foods, there's a chance, of course, where you're creating trans fatty acids, and you may be eating them, and eating too much of them will take a toll on your health. I want some fries now. Anyway, if we were to continue to look at this, can I take away these two? Well, yeah, you can, but if you'll notice that it's the same thing as that. So there's really no point. Okay. Now, I can tell you right now that there's one more. Okay, there is. It's a rare occurrence, but it can occur. Remember what I said about these bonds? They are free rotating, meaning that at a certain rotation, these two hydrogen can get together. Now think about it. If these two hydrogen can get together to form H+, what can you say about this carbon and this carbon? They're missing bonds, aren't they? So it's not likely, but it can happen where this carbon decided to bond with that carbon to make a cyclobutane. Okay. So this compound right here have the capability of making 3 different types of hydrocarbon, of course, plus H2. All right. Anyway, hopefully you guys are okay with that. So that's why I said that reaction of organic reaction is much more difficult than inorganic reaction. Like, remember those synthesis, decomposition, double displacement? Those were jokes. This, you really have to think and think, now how many different scenarios can there be? Alright, so that's dehydrogenation of alkane. So let's move on and let's take a look at another type of reaction. Okay, this is where I want to get to. This is reaction of alkene. So we saw how we are able to make alkenes from alkane using dehydrogenation. We can now take a look at how alkene can react. So the first reaction that we're going to look at is called halogenation. Now obviously this has something to do with halogens. So what that is this. If you take an alkene and you react it with some sort of halogens, okay, what you're going to get is an alkyl halide. Now, we've seen alkyl halide made yesterday. So when we took alkane and we reacted with an halogens, we call that substitution, and that also makes an alkyl halide and an acid. Well, if you take an alkene and you react it with the same halogens, you can actually also make alkyl halide. And the good thing is, you won't make the hydrogen chloride, hydrogen bromide type of gas. So let me just show you an example here. I have ethene. Okay, the simplest alkene. And I'm going to react that with F2. Okay, let me stress the F2. F2. There you go. Supposed to be single bond. Now, what happened here is this. You see this bond over here? This one of the double bond? That's going to break. Okay? By breaking, this carbon is going to say, I'm going to hook up with this fluorine, and this carbon says, I'm going to hook up with this fluorine. So, as a result, when the double bond breaks, what you're going to get here is an alkyl halide. Okay, it's a different type of alkyl halide from the alkyl halide we saw yesterday with substitution, because both halogens are going to be part of this alkene. Sort of like a synthesis reaction where you have two to become one. Alright? Hopefully that is simple enough. And the good thing about halogenation is that there's really no tricks. Like, if I were to take butene, okay, one butene, Okay, and I react it with, let's say, Br2. So again, same idea. This is going to break, and what you're going to get, of course, is this little compound right here, which I'm going to stop drawing hydrogens for. You're going to get that. Okay? Now, does it get trickier? Absolutely. What if I have a multiple alkene? And I'm reacting it with chlorine gas. What am I going to get? Oh, I keep forgetting about catalysts. Shame on me. In order for this to work, 25 degrees Celsius has to maintain. Okay? So I guess I should really put this down, because if I don't put this down, you have to think that this reaction will not occur. Okay? All right. So you have 1 mole of this guy. Okay? Let's just name him 2. 1 4 hexadiene. Okay, 1,4-hexadiene. React it with 1 mole of chlorine gas. What are you going to get? Well, you're going to get this. Okay? So that is 1,2-dichloro 1,2. Well, like 5,6, I'm sorry. 5,6-dichloro 2-hexene. Okay? Now, is that the only thing that you're going to get? No. You might get this. Okay? Where the chlorine not only can attack this double bond, but it can attack this double bond. Okay? So, because of that, this is something different. If I were to ask you to name this, this is not going to be 5,6-dichloro 2-hexene, would it? Okay? It will be 5,4,5-dichloro 1-hexene. You see? Now, will there be a situation where both of these double bonds are attacked and you have a whole bunch of chlorine gas? Yes, but not in this case. Not for this question. Because for this question, I've mentioned the fact that I'm only using 1 mole of chlorine gas. So, if there's a question that looks like this, and all I did was changing the chlorine gas, and I write that this is in excess. Okay? And under 25 degrees Celsius. Now my answer will be different. Okay? Because this guy is in excess, that means I have many of these to potentially react with many of these. Or it could be just one of these. Okay? So the way we use excess here is that we have a lot of chlorine gas. Not just for this example where we say we have one of these and one of these. So your answer will be this. And theoretically you should say or this. You will have both. Okay? Due to the volume, you will have this or this. Okay? But when you have an excess of Cl2, this might happen. Where both double bond are going to be cleaved by chlorine gas. All right. So for this one, there is no more alkene. So you're just going to be counting where those chlorine is linked. So that's 1, 2, 4, 5. Tetrachlorohexane. Okay, so be careful. Look for this just in case. You don't know if you're going to be tricked for some sort. Okay. All right. So that's halogenation. So the next one I'm going to talk about, let's clear this up. Number 2 is the same thing really as halogenation. It's actually the reverse of dehydrogenation, called hydrogenation. Hydrogenation. Okay, so if dehydrogenation means to take hydrogens away from an alkene to make H2 gas, hydrogenation means taking H2 gas and put it back to an alkene. So it's actually the reverse of what we looked at earlier today. So let's take a look at an example here. So you have an alkene and you're reacting with H2 gas. Okay? Under heat, you will make an alkane. Okay. So we have an alkene right here, ethene. Okay, if you react this with hydrogen gas, just like what we saw with halogenation, this H comes over here, this H comes over here because this double bond broke. Here's your alkene. Here's your ethane. All right. So the same thing would apply if you have multiple double bond. You have to look for, if I ask, so I'm going to have 1 mole of H2, or this is in excess where multiple double bond can be cleaved by H. Okay. So let me give you a question here to do. I'm gonna not write the hydrogens. I have this. Okay. Triple alkene. And I'm gonna react this with H2. And I'm gonna have some heat. Tell me how many different products am I gonna get? Okay, so I want you to maybe pause this video and figure it out and unpause whenever you're done. Okay, so after unpausing, let's take a look. So hydrogenation of this alkene. So you can see that, okay, this looks like an hydrogenation type of question. I'm going to insert H2 into this organic molecule. And does this organic molecule have double bond? Certainly, because this have the ability to break these double bond and hook up with the carbons that have their double bond broken. So it looks like I have this position, this, and this. So it seems like I'm probably going to have 3 different types of product. And most likely your teacher is going to ask you to name them, like me. So the first one, let's have this one broken. So if this one was broken, no problem. That's what you're going to get. Okay, so what if this one is broken? Again, not a problem. Okay, and of course, if you break this one, there you go. Okay, Now, you gotta say that all of these are different. Okay, they're not the same. They all have different name. And I'm sure you guys are capable of naming all of these things and note that, ooh, they are different. Okay, so remember that you have to make sure that you understand that this reaction is a hydrogenation reaction, and hydrogenation reaction strictly attacks double bond. Okay, it's very, very similar to halogenation. The difference, of course, is that this is not a halogen. That's all, but it's really the same thing. Okay, and the second thing, of course, look to see if this is in excess, because if this is in excess, this is going to be different. Okay, you're not going to get 3 products. You're just going to get 1 product. And that product, of course, is the breakage of all 3 of these all at one time. Okay. All right. So that's my second reaction. I have one more reaction to do today. So let's clear this. Okay. I promise you, this is the last one for the day. Okay. This is called hydrogenation. Oof. Hydrogenation. Now, what is that? That's some crazy name. So if you take alkene and you react that with, let's say, an acid. To be specific, a binary acid. Or a gas. No big deal. And it is 25 degrees Celsius. You're going to get an alkyl halide. Oh my god, alkyl halide is back again. Okay, so here it goes. So I have ethene again. A binary acid like HCl, okay, under the influence of 25 degrees Celsius. This double bond will break. This H will come over here. The Cl will come over here. As a result, you have this alkyl halide. Okay, this is of course 1-chloroethane. Okay, simple, right? Well, not all the time. Not all the time. How about this one? Okay, 1-propene reacted with HCl under 25 degrees Celsius. What will this one be? Now, why did I say this one is more concerning than this one? This one seems simple. This one, not so. Think about it. This H and this Cl will break apart. This H or the Cl can say, oh, well, since this double bond is going to break, this H I can go with over here. And Cl come over here. No problem, right? Of course. Of course, no problem. You're going to get this. No big deal. Let me just draw all the H's for today. Okay? But who said this has to be the case? Why can't the Cl come over and hook up with this carbon? Well, you know what? You can do that. Why not? Right? So, in a situation where your double bond where alkene has more than 2 carbon. A hydrohalogenation reaction can have multiple scenarios because both of these are different. Okay, because if you were to name them, this is 2-chloropropane. This is 1-chloropropane. They're 2 different things. That's why they have 2 different names. Okay? So when this double bond breaks, this carbon can say, I want to hook up with this guy, or I can hook up with that guy. So in this case, you will have 2 different answers. Okay, so that's hydrohalogenation. So it can be very tricky. Anyway, homework time. I want you to figure out this question. Okay. Right? Plus HCl under 25 degrees Celsius. What am I going to get? How many am I going to get? Okay, so let's call it for the day. I think 3 + 1 reaction today is a lot. Okay, so I think it's a good time to stop. Now, I'm not done with reaction of alkene though. I actually have one more reaction of alkene. I'm going to have a number 4. And this is going to be called hydration. This one is going to be tough. Okay, but we'll look at it next week. So until then, I'll see you next week. Bye.